The table gives the number of people in the audience at Ms. Bart's TED Talk. When he starts at 7 p.m., T equals 0. There are 14 people in the audience. 9 minutes later, T equals 9. There were 59 people in the audience. 45 minutes later, T equals 45. There were 105 people in the audience. The number of people in the audience can be modeled by the quadratic function P given by PT equals AT squared plus BT plus C, where PT is the number of people in the audience, T minutes after the TED Talk. Use the given data to write 3 equations that can be used to find the values for constants A, B, and C as decimal approximations. So we are given 3 points and told the situation follows a quadratic equation PT equals AT squared plus BT plus C. Our goal is to find A, B, and C. So we take each point and plug it into the equation. The points are 0, 14, 9, 59, and 45, and 164. So first we get 14 equals A, 0 squared plus B, 0 plus C. So next, then we get number 2, 104 equals A, 45 squared plus B, 4 plus C. Then number 3, for number 3 we get 59 A equals A, 9 squared plus B, A plus C. And then we put that into decimals and get A equals 0.083, B equals 5.75, and C equals 14. B1. Use the given data to find the average rate of change in the number of people in the audience from T equals 9 to T equals 45 minutes. Express your answer as a decimal approximation. Show the computations that lead to your answer. The equation is F45 minus F9 over 45 minus 9. So then we subtract the outputs and divide by time, which is 104 minus 59 over 45 minus 9, which equals 45 over 36. Then simplify, it would equal 1.25 people per minute. B2. Use the average of rate of change found in 1 to estimate the number of people in the audience at the time T equals 30 minutes. Show the computations that lead to your answer. So the equation would be y minus 105 equals 105 equals 125, 30 minus 45. Y equals 125, negative 15 plus 105 equals 86.25 people. The average rate of change found in I can be used to estimate the number of people in the audience for times T equals D minutes, where 9 is greater than D greater than 45. All these estimates less than or greater than the people in the audience predicted by P at time T equals D minutes. Explain your reasoning. Your explanation should include characteristics of the average rate of change and a reference of the graph of P. The graph would look like concave down, 9 would be there, 45 would be there. The estimates are the secant line on the interval line. The graph of P is concave down on the interval, so the estimates are less. Question C. The model P is an appropriate model to take predictions about the number of people in the audience if the predicted number of people in the audience is at least 0. Based on the information, what is the largest value for T for which model is appropriate? Give a reason for your answer. So P has a 0 at 71.354. So fans eagerly anticipated the new Algebros math video, and so the first day, t=0, that it was released on YouTube, it had 85,000 views. 45 days later, t=45, there were 110,000 views. The number of views of the Algebros new video on a given day can be remodeled by the function v by vt equals a plus b natural log t plus 1, where vt is the number of views in thousands on day t since the initial day it was released. A. Use the given data to write two equations that can be used to find the values for constants a and b in the expression for vt. So we are told at=0 and the views equal 85,000 and 1,000. t=45 and the views equal 110,000. So first we're going to plug the values into the formula. Use t=0. Equals 0. A plus b natural log 0 plus 1. So that becomes 85 equals a plus b natural log of 1. So since the natural log of 1 equals 0, this becomes 85 equals a. So next, we've already found a equals 85. Now plug the second equation. 110 equals 85 plus b natural log of 46. So we subtract 85, 25, B. Natural log of 46. So now we solve for B. So B equals 25 over natural log of 46. So then that equals B equals 6.529. So that would be A equals 85 and B equals 6.529. Okay. Use the given data to find the average rate of change of number of views of the new algebra's video in thousands per day from t equals 0 to t equals 45 days. Express your answer as a decimal approximation. Show the computations that lead to your answer. So first, it's going to be V 45 minus V 0 over 45 minus 0. Then that would be 110 and 85 over 45. That would equal 0.556 thousand views per day. So B2. So use the average rate of change found in I to estimate the number of units of views in thousands. On day T5, 25, show the work that leads to your answer. So we're going to estimate at T equals 25 and use the point slope form with slope equals 0.556. So we're going to plug in T equals 5. Equals 25. And then that would be y equals 85 plus 13.9. Then that would equal 9.89 thousand views once you plug that into the calculator. So number 3. Let AT represent the estimate of the number of views of the new video in thousands using the average rate of change found in I. For A25 found in II, it can be shown that A25 is greater than V25. Explain why in general. AT is greater than GT where 0 greater than T greater than 45. So since the function is concave down, the function is concave down, the secant line between T equals 0 and T equals 45 lies below the graph. So the estimates is less than the actual value. So C. The algebras reported that daily views of the new video decrease each day after T equals 45. Explain why the error in model V increases after T equals 45. So the model continues to increase, which it does, but the row data starts decreasing. So after that, after t equals 45, so the difference between the model and the actual values gets bigger. And increases the error.